Alright, so we're just going to do a bunch of examples now. Before you begin solving by factoring, the thing is to use the zero product property, then you must have one side, that equals 0. Because you can't use a zero product property without one side equaling 0. So one side must equal 0 and the equation must be in standard form. So just going with our first example down here, one side is equal to 0, the left side is in standard form, so I can go ahead and factor this. What multiplies to 14 but adds to 9? Well, that's going to be 7 and 2. And now I do not have a coefficient in front of my squared term, which means I can just have my factors as k plus 7 and k plus 2, and all of that is equal to 0. And now, because I have two things that multiply to be 0, the zero product property says that one of those things has to be 0. So I'm going to set each individual factor equal to 0, which gives me an answer of k equals -7 and k equals -2. Part B over here, when I look at this one, I want to remind you that the first thing we look for is a greatest common factor. And some people might not think this has a greatest common factor, but I just want to remind you that if the leading term is negative, factor out the negative as a GCF. So with example B here, I see that my first term is -x squared, so I'm going to factor out that negative to give me x squared plus 4x plus 4 equals 0, because it was like dividing everything by -1. Because now I can go and factor what's on the inside here. What multiplies to 4x squared but adds to 4? Oh, well, that's just going to be 2 and 2. And because now I do not have a coefficient in front of the squared term, remember your GCF carries down, and I get x plus 2 times x plus 2 equals 0. And now I have all these things multiplied to be 0. So the zero product property says that one of them has to be 0. So that means either x plus 2 has to be 0, or the other x plus 2 has to be 0. Or this negative, think about this, I could also write this as like a -1. So this says that either -1 has to be 0. Is -1 equal to 0? No, it is not. So that tells us that a GCF is not going to affect your solutions, because no matter what I do, that -1 will never equal 0. And so I can just go through and solve with my other factors. So I get x equals -2, and another x equals -2. So they're the same answer. So you can just write it once, that would be okay in that situation. Okay, if I go to example C, first thing I notice is that this equation is not equal to 0, so I'm going to add that 2 to the other side. I do not see a GCF. Excuse me. So I multiply the first and the last term. I get 12k squared. And I'm looking for two numbers that multiply to 12 and add to 7. Well, I know that's going to be 3 and 4. This time I do have a coefficient in front of my squared term, which means I cannot use the shortcut, which means I'm going to substitute 3 and 4 in for that 7. So that's 6k squared plus 3k plus 4k plus 2 equals 0. And now we're going to do factoring by grouping, meaning we split it in half and we factor out the greatest common factor from each half. So the left side, I see they both have a 3 and they both have a k. And so dividing everything by 3k, I get 2k plus 1. And the right side, they're both divisible by a positive 2, which gives me a 2k plus 1. Hey, those are the same thing. Means we did it right. So I can factor out that 2k plus 1 from both of them. And when that happens, I'm left with 3k plus 2. So that's the factoring part of it. Well, now, zero product property says that I have two things that multiply to be 0, so I know that one of them has to be 0. So I keep solving. 2k equals -1. Or I'm going to rewrite this over here just so we have a little bit more room. 2k equals -1 divided by 2. K equals -1/2. It's one of my solutions. 3k plus 2 is my other one, so I can subtract 2. And k equals -2/3 as my other solution. Okay. Example D doesn't equal 0, so I'm going to subtract 3. Hey, this is a difference of squares. Difference meaning subtraction and two things being squared. So I could either substitute 0 into the middle here, or we talked about one of our shortcuts, is we can just take the square root of both of these. I get an x plus 5 and an x minus 5, because the square root of x squared is x, and the square root of 25 is 5. And the reason one is plus and one is minus is because they have to add to be 0, like we did up in this example for part B. You see how they had to add to be 0? So we're just using our shortcuts where we can use them. So once again, zero product property says that if two things multiply to be 0, then one of them has to be 0. So I get x equals -5 and x equals +5. We're just having a grand old time, you know, just factoring away our lives. Okay, I'm going to skip down to examples G and H, because E and F are pretty much everything we've already done. Part G, the first thing you look for when you factor is a GCF. So I see both of these have n, which leaves me with n minus 7 equals 0. Look at that, it's already factored. And I've had people ask me before, how do I know if that's factored? Well, you don't have anything squared anymore, so that's how you know it's been factored. And in this case, I know that two things multiply to be 0, so one of them has to be 0. So that tells me that either n out here has to be 0 or n minus 7 has to be 0. Well, that variable is already by itself, which is cool. So that's the third tip I want to leave with you, is that a variable out front gives a solution of 0. Okay, part H, I'm missing my middle term here, which should be like a hint to me to use difference of squares, but the problem is this is addition. So if it's addition in here, the way we made it fit difference of squares is to make it subtracting a negative. And now I can still do my square root stuff. The square root of 4a squared is 2a. The square root of negative 121, well, the square root of 121 is 11, but negative 11 just makes it an I. This is a quick side note refresher. So I have two things that multiply to be 0. So I'm hoping you're realizing, oh yeah, zero product property says that I can set both of those equal to 0. And now we're just going to solve for a. So a equals negative 11i over 2 as one of my solutions. And a equals positive 11i over 2 for my other solution. Okay, if you have any questions about solving by factoring, feel free to reach out to your teacher.